Hello guys and welcome to this webcast. My name's Jazz and I'll be guiding us through how to go about defining a set of equally spaced shelves and doing that in a software package that we utilize called SWOODdesign. So first of all, let's kind of go about defining ourselves a project brief, looking at a particular workflow. What I'll be looking at doing here is setting up a set of equally spaced shelves and following the parameters that we've got outlined there on the presentation slide. So I'll be looking to define a 1mm offset for the shelves, and that's working from kind of left to right as we would be putting them into the cabinet. And then looking at other kind of alternatives as well, so the ability to control the front and rear offset. So in this particular example, if we were looking to put any electrical cabling up the back of the frame for the SWOODBox, then that's the ability to control the front and rear offsets. Alternatively, we will be looking at several options as well in terms of how to support the shelves and the kind of properties of each shelf as they're brought into the SWOODBox. So we're going to be looking at four options in terms of the holes. First of all, no holes as an option. We'll then look at an option of one pilot hole per shelf into the side of the cabinet, 3 holes per shelf, and finally a row of holes. Moving on from that, we will have a look at 4 different connector options as well. So just looking at the variety in terms of providing a SWOODBox with different connector options as we look to specify the furniture come the end of the SWOODBox. So the 4 options we'll be looking at in this case are the 4 listed on the screen. So we'll have a look at no connectors as an option, shelf studs, wedges, and finally plastic supports. As I guess a bit of an extra, we'll also have a look at how to define a shelf as a rebated option. Okay, so moving on, we'll look at the definition first of all of the SWOODBox. So I guess this is crucial before starting any project, kind of outlining the design intent of the SWOODBox, and knowing where you kind of want to go with this early doors will help kind of with the outline of your SWOODBox and the kind of initial definition. So just to control those offsets that we mentioned, kind of from left to right, as well as the options from front to rear, we'll be looking at defining additional reference planes within inside the SWOODBox environment, as well as mirror planes as well to assist with the definition of those connectors as we bring them in a little bit later on. So rather than having to duplicate the efforts each time, we can use the components to pattern them within inside the SWOODBox. Okay, so I've just got a small video inside this PowerPoint slide, and it's just going to take us through the steps of defining that SWOODBox. So I'm just picking up on the templates first of all, and you can see the predefined SWOODBox as it's been created. Now I'm not looking to bring in any particular components on startup, so I'm just closing down the insert component options. And I'll start by saving this as a project, and that's just specific to the data directory inside of our SWOOD environment. Okay, now looking at the first reference plane, I'm just going to look to create myself an offset plane from the back of the SWOODBox. Now the initial value of 50mm isn't too crucial. We will be looking to control that at a later date, but what is kind of more necessary is the renaming of these planes. So this will just assist if the project is to start to become very complex very quickly, then we know exactly which planes and which selections we're making from our feature tree. So as you've seen there, we've just created a one for the back offset and the front offset, and now in turn we'll be looking to create a similar sort of setup for both the left hand side and the right hand side of the SWOODBox. Now the difference between the front and back and the left and right is the values that we've defined there. So the 1mm is very much the specific value I want for the left and right offset, whereas the front and back it should have the ability to vary. Okay, and we'll see how we can control this again a little bit later on in terms of the SWOOD code that we will write. Okay, so just defining the left and the right offset here. Okay, now moving on to the next plane set, we will be looking at creating that mirror plane as we mentioned. Okay, so first of all creating one from front to back. Okay, and it's just going to be a mid-plane option between the two, and we can see that it's positioned nicely halfway through the SWOODBox. Now we'll look to rename this plane again, okay, to follow suit with the rest of them on the feature tree. and then one final reference plane to create the same sort of effect moving from left to right. So you can use your flyout feature tree here to select the corresponding planes. So we're going to go for the left and the right. Okay, confirming that plane creation again on the feature tree, we're just going to look at renaming it. Okay, and I'm just going to update the file with a final save. So you can see there how early doors I've set up the planes needed to kind of work through the definition of this SWOODBox. And having done that, what we'll look to do next is make our way through to creating the shelves. So just before I get started inside of SolidWorks, we'll just have a look at the definition of how we want to create those shelves. So the fact that we want them to be equally spaced will be quite crucial in terms of how we set these up inside of a SolidWorks environment, and in particular the code that goes into the SWOOD parameters in the background. So just looking at the diagram and the key there on the screen, the H is the definition of the overall height of the SWOODBox, and within that we've got the definition of the shelves and the space in between those. So you can see from the key, to work out what the spacing is required for between each shelf, I've worked out the thickness of the shelves in turn and multiplied that by the quantity, and we've worked out how many spaces we'll have within inside the SWOODBox. Now ultimately, for a set of equally spaced shelves, that is the multiplication of the shelf spacing against the quantity plus 1. So you'll always have a definition of an extra space in comparison to the quantity of shelves. Okay, now having defined that, we'll look at setting up the first shelf inside of our SWOODBox. So we'll have a look at utilizing those control planes that we created earlier. So just moving back into the SolidWorks environment and using our SWOOD toolbars across the command manager, we're going to define our first shelf, and for argument's sake we're just going to call this panel 1. Okay, you'll see the property manager for SWOOD pop up after that, and we're just going to utilize the planes that we created to define the definition and dimensions of that shelf. So by selecting the planes collectively using your control options and clicking the icons within the panel window on your feature tree, that'll help define the shelf to the specified values of the space in between each reference plane. Now, having defined the plane, what's left to do is kind of position it nicely within inside the SWOODBox. So that's just using standard SolidWorks functionality in terms of applying mates inside an assembly environment. So you'll see we've positioned it nicely from front to rear there using a nice symmetrical mate, and we're going to do a similar sort of thing working from left to right. So I'm just picking up the plane that's situated down the middle of the panel and the two corresponding planes in the SWOODBox environment. Having positioned that, what's left to control is the height. So this is looking back at the diagram that we had on the previous slide of the presentation, and I'm going to look to define the offset height. So working with the plane at the bottom of the SWOODBox and the underside surface of the panel, I'm going to set a distance mate of 250 millimeters. Now again, the initial height of this isn't overly crucial. Okay, that will be controlled at a later date within inside the SWOOD environment. Now, having defined that first shelf and knowing that they need to be equally spaced, we can make use of the linear pattern tool inside SolidWorks. So just selecting that SWOODBox bottom plane again, just to help control its orientation and direction, I'm going to set a spacing of 100 millimeters and an instance of 4. And what we'll see is once we select the component to pattern, those instances come into play. Now the crucial thing to look at here are the values that we've defined. So we can see the 4 instance count and the 100 millimeter spacing. Now again, I keep referencing the fact that we will come back to these dimensions when defining the code for the SWOODBox environment. But those values are crucial to help define the parameters at a later date. So the next thing we need to consider designing is the connectors to support the shelves within inside the SWOODBox. So there's a few things to consider when you're looking at your connectors. First of all, what type of connectors you want to bring in. And having decided that, we'll then look at controlling the position of the connectors within inside the SWOODBox and inside the SolidWorks assembly. We'll also look at considering which features, if at all any, are needed to be kind of reciprocated inside of the part of the panels within the shelves. in order to accommodate those connectors. And then we'll look at utilizing the mirror tool and the linear pattern tool in order to create and duplicate the effects of those connectors throughout the various shelves that we have inside of the SWOODBox environment. Finally, we'll then look at dynamically linking the connectors to the shelves so that when the shelf updates with inside of the SWOOD environment and the SOLIDWORKS assembly, the connectors kind of follow suit and move in turn. So again, just inside of our PowerPoint here, we've got another video with inside of our SOLIDWORKS environment, and we'll just show you through the process. So we first of all working with some kind of top-down assembly modeling techniques whereby we're editing the panels with inside the SOLIDWORKS environment. And what we're doing here to start with is just creating ourselves a sketch on the side of the panel, ready to kind of create those cut extrudes that are going to be needed to locate the shelf studs with inside of the shelves. So we just used a couple of sketch relationships there, particularly the equal sized one to control the diameter of the circles, and finally putting in some dimensions to control its location. Now in this case we're just using some global variables inside of SOLIDWORKS environment to link the offset from the front and back of the shelf to be exactly the same. Following that, we're then putting in a cut extrude just to control the depths of these cuts, and you'll see these get positioned inside of the shelf environment. Now, just following the kind of process that we were working with earlier, we're going to rename these features, and again this will assist ourselves and make life a little bit easier when we come to define these parameters with inside the SWOOD environment. Having renamed those, we're just looking at duplicating the effect of that across the panel by creating a mirrored feature to move the cuts or duplicate the cuts from left to right. Again, we're going to rename this one just as we have done with the previous features. Now, having defined those features with inside the environment of the panel, what we'll look to do is we'll look to kind of replicate those effects across the shelves. So you can see the shelves have had the cuts created from them, and that is due to the fact that the cuts have been placed with inside the shelf environment and they've been duplicated due to the pattern that's already inside the SOLIDWORKS environment. Now what we're looking to do here is bring inside the connectors within our SWOOD environment. So you'll see we've got a simple shelf stud, okay, and what we'll look to do is pattern this throughout the SOLIDWORKS environment, but first of all we just need to locate it using our standard SOLIDWORKS functionality of apply and mates. So just putting in a concentric mate to align the stud with the hole cut that we've got on the panel itself. But you can see this time it is just the wrong way around, so I'm just going to expand my mates folder on the left hand side and I'm just going to reverse that alignment. Having done that, what we'll look to do is we'll look to align the stud with the outside edge of the panel itself. And what we now have is a stud kind of positioned exactly where we want it. Now, having brought in one instance of the stud, what we'll look to do is we'll look to mirror that stud across from front to rear of the panel before going from left to right. So just using the mirror component here, I'm just going to select the plane that I want to mirror the component about, select the component itself, and then confirm the command. Having worked from front to back, what we'll do is we'll replicate that procedure, this time going from left to right. So we're just using those mirror planes we created earlier. You'll see it's picked up the two shelf studs, and as we confirm these, okay, so we're just picking up the connectors there. And as we confirm this command, what we'll see is those studs have been patterned going from left to right. So if I rotate the assembly around, what we'll see is those have been duplicated across. So again, just following the same kind of protocol from before, just going to rename these features. So the first mirror was from front to back, particularly for the stud component. So just giving this stud mirror front to back. Okay, it's the second feature here now that we'll rename, and again we'll rename this with a similar kind of naming convention, going from left to right. Okay, now having patterned them for the first panel, what's left to do is control the linear pattern so that these studs can be replicated for the shelves throughout the assembly. So what we've done there is we've selected that bottom plane again from the SWOODBox environment to control its orientation and direction, and then we're selecting the components that we want to pattern. So we're selecting each of the 4 studs, and you'll see by confirming that command, those studs have been duplicated across each of the shelves in turn. Now, one crucial thing once we've renamed the feature is to connect them to the rest of the assembly. So you'll see what we're doing here is we're linking the instance count of the linear pattern for the studs with the instance count from the linear pattern of the shelves. Likewise, we're linking the dimensions, and what this will allow for is if the shelves spacing and instances counts increase, then likewise the studs instance count and distance will also increase. So we've just aligned those using kind of standard equations with inside of SOLIDWORKS. We've renamed our features, and what we can do once we've defined the first connector is look to duplicate this effect throughout the rest of the connectors within our kind of design brief. So we're just working through the one example in the PowerPoint, but as we mentioned in the brief, we do have wedges, plastic supports, along with rebated shelf options, which we'll look to address kind of throughout the rest of the presentation. Okay, but those are some of the considerations needed for defining connectors. Okay, so as we mentioned with your wedges and your plastic supports, the process is replicatable. Okay, so we just need to consider whether there's any sketches or features needed within inside the environment of the panel themselves, just as we have done in that environment there. Then consider whether the patterns or the connectors need patterning from left to right, front to rear, okay, just as they have done in the remaining examples. And then dynamically linking those connectors to the shelves. So as the shelf updates in terms of their instance count and the spacing, then likewise the connectors will also update. So having defined the shelves and the connectors, what we look to define next is what we term machine definition. So what this will allow us to do is control the positioning and the type of cuts needed for those connectors when positioning this SWOODBox into kind of the outer carcass of a SWOOD frame. Okay, so what we'll need to do here is define the type of holes that we want and where they are to be positioned depending on the type of connector which is in use. Okay, so what we'll look to do here again is just show a small SOLIDWORKS video kind of defining how we go about setting that up. So in here what we're going to do is we're going to kind of restrict ourselves to defining one side of the SWOOD framework. And then what we'll be able to do is duplicate the effects just as we have done with the previous patterns across to the left hand side. So working with the studs that we put in earlier, what we're doing here is defining a couple of sketch points to be positioned at the center of those studs, which will help control the location of the machine defined holes which will be replicated into the SWOOD framework. So using the linear pattern, what we're doing is we're selecting those 2 sketch points that we put in inside the sketch, and we're duplicating those across each and every shelf within the SWOOD environment. Having defined those, what we're going to look to do is define a few dimensions to go alongside of those. So we're currently just setting them at the default 100 spacing. Now what we'll be more interested in doing is looking to connect that 100mm dimension to the dimension of the pattern of the shelves. So by linking it through the use of equations, should the shelf spacing update, then the position of the machine defined holes should also update. Likewise, what we're doing here as well is linking the instance count of those holes to be the same as the instance count of the shelves within the SWOOD environment. Now, having created that sketch, what we'll look to do is we'll look to rename it, and in this case it's the ones to define one hole per shelf. Having defined that as a feature, what we'll then look to do is drop into the SWOOD environment. Now, under the second tab within the property manager of the SWOODBox, what we've got the ability to do here is define the machine definition. So we've just created ourselves a parameter here, which is going to control the visibility and the size of that whole sketch. So by linking the sketch to the parameter, what we could do up at the top section of the property manager is define where we want those holes to be positioned, whether it's the left hand side of the SWOODBox, the right hand side, the front, the rear, and so on and so forth. Now, having defined one parameter for the one hole sketch, what we'll look to do is we'll look to replicate that for each and every type of option that we want, whether it's the 3 holes per shelves, the row of holes, or in this case we're going to work through the example of the rebaited shelf. So in this case it's not a circular machine definitioned hole that we want, it's a rectangular cut to be positioned in the sideboard of the frame. So just create ourselves a rectangular sketch, and we're just using the collinear sketch relationship to align the parameters with the shelf. Now we're using the smart dimension tool again to link the dimension of the height of the cut to be the same as the depth of the shelf. So by making those dimensions visible, by double clicking on the feature on the left hand side, we're just setting the depth of the rectangle to be the same as the depth of the shelf. Having created one instance of the rectangle, what we're going to look to do is utilize that sketch pattern tool again to increase the increment count of that sketch and pattern it for each and every shelf within the SWOOD frame. Now, having patterned it, what we're left to do is define it to make sure our sketches are fully defined. Using the Smart Dimension tool again, what we're doing is we're going to select the base entity of the sketch we created and the base entity of the next instance, and once again we're going to link the dimension to the distance of the shelves. So using those instance counts and the distance spacing between the shelves, we're going to link it so that we've got 4 sketches to each and every 4 shelves. Now what we'll look to do here is add this to the machine definition. Now this time it's an extruded cut that we've created. So we've used the extruded cut option under machine definition. And what we're going to do is we're going to link it to that sketch. Now albeit in this case I haven't renamed the sketch, so I'm just dropping back to the property manager or the feature tree so that we can link the sketch appropriately. So I'm just going to rename this one. And we'll rename it Rebaited Cut. Moving back to the SWOOD environment, you'll see the sketch has updated itself, and we've now got 2 machine defined parameters. Now what we'll look to do here is create ourselves a compound machining, and this is due to the fact that we've got multiple variable options within inside our SWOODbox as per the design brief. So we're creating ourselves a compound option whereby we can link each and every machine definition to be a part of the compound option. So by dragging them and dropping them in the below box and linking that back to the machining, we can utilize that compound machine definition that we've created to replicate the holes onto the side frames of the SWOOD frame as we put the SWOODbox inside of it. You'll see here what we can do when we're testing the environment is define the depth and diameter, and albeit both sketches are shown, both for the circular cut and the rectangular one, we will control the visibility of these throughout the coding within the SWOOD environment. So we'll have the option to suppress one or suppress both of them, depending on the options which we define in the SWOOD environment. Now, having defined this, we've mentioned the parameters on numerous occasions, and what we'll look to do next is define these within the SWOOD environment. So just to run through a few of the parameters before we go ahead and do that, what you'll notice inside of the SWOOD environment is there's several different options for the various different parameters that we can utilize. Now inside of this SWOOD example, what we've utilized is strings, dimensions, booleans, and integers. So what you'll see here is the string parameters. Okay, so what we've got here is 2 options. We've got the connectors and we've got the holes per shelves. So by specifying on drop-down menus of what type of connectors we want, we've defined these as string parameters. Now you'll see the aliases aligned in the table, there to denote what the parameter is labelled as inside the coding that we write in the background. In terms of whether they're exposed or not, that is whether they're visible on the SWOOD menu to control externally once dragging and dropping the SWOODBox into the SWOOD frame. In terms of possible values, we just list the various options that we like to define as this parameter. Moving on to the numeric options, what we've got quantity, and again we've assigned itself an alias. We've asked for it to be exposed so that this can be controlled within the SWOOD environment, and again that will be linked to the shelf pattern instance count. So should we increase the quantity of the SWOODBox, what we'll find is the instance count of the pattern driving the number of shells and their visibility will be increased due to the code that is controlling it. We then look at the dimension ones. Now there's several options for this one. I won't go through each one in turn, but if you'd like to take a moment just to pause and have a look at the various options that we've got set up. These are controlling various things like the front and the back offset of those planes that we created right at the beginning, along with the internal spacing and the shell spacing. Now with those two particular parameters, you'll notice that they're not exposed. The reason for this is we don't want these to be controlled manually by the end user. These will be driven by the code in the background of the SWOODBox. Finally, we've got the Boolean parameters, okay, and what this controls is the suppression of each of the features in turn. So if we want them to be suppressed, then in the background the code is choosing which parameters and which features of the SOLIDWORKS model is being visible or hidden in the background. So having defined the shelves, the connectors and the machine definition, the last thing that we need to define are the parameters. So hopefully the few slides kind of before this one have helped kind of iterate what we are defining as parameters and how we would go about setting those up. And that's what the video in this kind of presentation slide will look to kind of demonstrate. So we'll have a look at kind of defining a couple of features, setting the parameters, and then controlling these through the functional code as well, which is ultimately what drives the SWOODBox in the background. So again, just playing the video that we've got here in the PowerPoint, you'll see what we've got on the left hand side there are the features that we've utilized and kind of created throughout this process. So we've got the shelf and the connectors and a couple of patterning features. Now ultimately, as I mentioned right at the beginning, we would be looking to do maybe a little extra in here as well and give ourselves an option of a rebated shelf. So ultimately the way we're going to achieve this is we've dropped into the panel itself, again using some top-down assembly modeling techniques, and we've just created our boss extrude to the size of the shelf and applied this to a certain depth to kind of replicate the rebated shelf extension. So we've created that on one side, again using our mirroring techniques. We're going to replicate and duplicate that across to the left-hand side of the shelf. Once again, for completeness, we'll rename that. And having done that, what we'll do is we'll look to exit the edit state of the panel, and we'll look to start to drive these through the SWOODBox environment. So dropping into the SWOODBox environment there, we'll look to kind of set up a couple of the parameters. Now you'll see by default that you've got a couple already set up, so the depth, the height and the width of the SWOODBox is kind of already defined. So we've just created ourselves a Boolean setup here for the kind of rebated cut sketch. And that's the sketch for the rebated element of the shelf, which will control the machine definition. So we've just given it a name, we've given it an alias, and now what's left to do is link it to a property. Okay, and what this will allow us to do is specify the property which the code will ultimately control the suppression of, depending on our parameters that we define inside the SWOODBox environment. So we're just going to link that to the rebated cut, and we're going to opt to have it driving, and that will mean that the kind of over defining or the aspect that controls it completely is within the functional code of the SWOODBox, as opposed to an option which the end user will be able to kind of manipulate. We're just creating ourselves a second suppression feature here, and this is for the physical element that's been added to the shelf. Okay, so those extended boss extrudes. Again, we're giving it an alias. Okay, we're defining the selection, and in this case there's two features. There's the initial extrude and there's the mirror feature which created it for the left hand side. Again, we're going to opt for this to be driving. Okay, and that's completed the definition of those two parameters. Okay, now ultimately in this SWOODBox there are a lot more parameters which need to be set up. Okay, but the process for doing so is exactly the same as what we've just seen there on the screen. So having reached the stage where we've gone through and defined all of the parameters and the shells and the connectors within inside the SWOODBox, what's left to define is the functional code which will control ultimately how the SWOODBox appears, whether the studs are shown as the connectors, whether it's the plastic supports, whether it's the wedges, along with all of the other variables which are likely to change due to what the end user specifies. So in terms of the functional code, what we've got to do is define the initial state, control those conditions of the holes per shelf and the machine definition features, as well as the choice of the connectors. Now ultimately, to define this functional code, we need to be looking at the SWOODBox kind of property manager. Okay, so you'll be familiar with the graphic that's just appeared on the screen. Towards the bottom of that graphical window is the functional aspect. So clicking on the icon to the right hand side of that window will allow you to kind of pop up an additional dialog box and start to kind of program the code ultimately which will control the SWOODBox. Now on the screen as well, what I've done is I've included the code which is kind of controlling the equal space shelves in the background. So you'll see the three aspects, okay, flicking up on your screen now. And as I say, what we've done initially is defined the parameters, and that's controlling the kind of suppressional state of the plastic support, the wedges, as well as the studs and the rebated shelf extends. Beyond that, you've got kind of if statements, which are ultimately controlling the visibility of all of those variables kind of as it goes through its various options. Now, having this code in play will allow the end user to define how the SWOODBox ultimately appears when moving this into a SWOOD frame. Finally, just to summarize what we've covered in this PowerPoint, we are coming to the end of the SWOOD project here, and just kind of reiterating what we went through in the design brief and the videos that have kind of been displayed in the PowerPoint. We've set up a set of equally spaced shelves as a SWOODBox, which will allow us to bring it into the various SWOOD frames that we'll create from this. So we've set up some equally spaced shelves with 1mm offsets on either side. And we've also allowed for the ability to control the front and rear offsets, as I mentioned back at the beginning, in case we wanted to put any electrical cabling down the back of the cabinet. On top of that, we've got several options with regards to the holes and the connectors that are to be used, as well as the extra of the rebated shelf. Hopefully the PowerPoint's been useful in guiding you through how to go about setting this up yourselves. But should you require any assistance or anything you just want clarity on what we've gone through today in this presentation, then by all means get in touch with us on support. The number and the email address is now on screen, so just drop us a line on an email or contact us through the helpline number, and one of the engineers on the line will be happy to assist in providing you some support for your SWOOD design projects. Again, thanks for watching.